Okay, yeah. Afternoon, folks. This is a lesson for Form 1 mathematics on the topic sets and Venn diagrams. So I'm just going to go through the concepts that we're going to cover in this series. Our interest here is to be able to identify how we draw sets using the roster and set builder notation. We might also be interested in interpreting a Venn diagram, understanding the concepts behind intersection, union, and complements. Then we might be given problems to represent using Venn diagrams. So let's have a look at these key ideas. A set, we define it as a collection of objects. There is an example given. A set can be A where we have even numbers. So I'm just rewriting it that set A, we denote it in roster form as 2, 4, 6. That's a set denoting those are even numbers starting from 2 but less than 8. Then a Venn diagram is a way of showing relationships between sets. A good example is we normally use a rectangle to denote a Venn diagram. So a shape like this, we might put a symbol like this to say this is our mother diagram or parent diagram. So we might have set A, if it overlaps, can see that with a crossover or a connection between set A and B. So the intersection from what I've drawn up there is the common point of link between the two sets. So we normally denote it using a symbol. This given symbol is an inverted, more like Q. So that's A and intersection B. We're looking for common elements between the two sets. Then union, these are all elements belonging to set A or set B. Or both. So we can denote it with two circles like this, whether they overlap or not. Where I shade is the union. So all this is what we'll be interested in. Moving on, complement. Say for instance, I've got my universal set or mother diagram like this. Say I've got set A and it overlaps with set B. If I say I'm interested in complement of B, so I'm saying B, if I use the sign as complement, I'm interested in everything that is outside of set B. So all the elements found outside of set B, that will be the complement. Then disjoint sets, these are sets which do not overlap, or in other words, they don't have a common point or an intersection. If I look at a rough example, I've got my mother set. If I have set A and there's no connection with set B, in other words, the intersection is empty, then we say they are disjoint. So let's have a look at how we apply this to solve problems. I've got about 10 problems that I'll quickly go through and we solve them together. Right, write the set 2, 3, 4, 5 is set builder notation. So set builder notation, we are simply saying within this we have got x such that x is, it might be a natural number bigger than 1 and less than 6. So that's what we have in set builder notation. There we are given set builder notation. We want roster. So roster is going to be, if I do this, I've got the letters A, P, E, L, E. Then I close my roster. That's the roster notation. Move to the next part where I've got sets A and set B. If I want the intersection, I'm looking for what's common between the two sets. If I check carefully, it looks like 3 here is common. So I'll use my set builder notation to say I see that 3 is common. So inside my set, there will always be one element that's found in the intersection. Then using the above, we want the union. So if we want the union, we are saying we are counting each element once, but there's no repetition for the repeated elements. So if I use set builder, in other words, I'm saying 1, 3, 4, 5, 6. That's my union because these are the elements found in both sets. Then I've got my universal set with numbers 1 to 10. So if I come up with my diagram, I'm told there's set A, but set A has got elements 2, 4, 6, and 8. And then I'm interested in writing a complement. In other words, I want what is outside A. So outside A, if these are my elements, it means I will have 1, 3, also I have 5, 7, 9, and 10. So those are the elements which are found outside A. So if I say A complement, this is what I'll get: 1, 3, 5, 7, 9, and 10. Then I close my set. Still moving, the sets A, B, C, D disjoint. Yes, we can say this is true because there's nothing in common there. It's true. And in other words, A intersection B is equal to an empty set, so they are disjoint. Then moving to 7, a Venn diagram shows 6 in A only and 4 in the intersection and 3 in B only. Find the total. So here we are being told of the number of elements that we find in set A, the intersection is set B. So if we want the total, which is union, in other words, we are saying A union B, this is going to be 6 plus 4 plus 3. So this in total will give us 13. When we say the intersection, we count it once. Now, the modulus absolute value is equal to 14, and the intersection has 6 elements. How many are in A only? So in A, we have 16, but the intersection has got 6. So what we know is in A, if this is the intersection and it carries 6, but in total set A has got 14, then it means outside or in A only, we have 8. So this will match A only. Then represent the two sets on a Venn diagram. So a Venn diagram, what will be interesting is to check, do we have an overlap between P and Q? I can see 3, 4, 3, 4 there. So I can come to say within set P, there's going to be an overlap with Q, but we have elements 3, 4 here. So in P only is 1 and 2, and in Q only, that's 5. I think that's how we represent that using Venn diagram. So it's the intersection of 7, 8, 9, and 1, 2, 3 empty. Yes, it's true. It's empty because we do not have common elements. I think that's it on the topic sets for the introductory part. Thank you.